let's start. This was not the original talk. There was a talk about serverless, but the guy that has to come from India had some issue with visa, and so I'm replacing the session. And today we're going to talk about Flutter and React Native. In particular, I want to give you an overview about the two frameworks in order to make you understand which could be the best suitable for you. I already presented myself back in the keynote, but I only told you what I do during the night. But during the day, I work at Uniwhere, where I do mostly Android stuff, but it happens that I had to deal also with iOS. And these are my social handles, if you want to stay in contact with me and stalker me, whatever, you are free to do. And okay, let's start. Sorry, I get back if you are taking pictures or stuff like that. Okay. Let's start with the disclaimer. All the stuff that I'm going to say during this talk is based on my experience. So an experience of object-oriented developer and a native developer. And of course can be a different experience from yours. I'm happy to chat with you about it. And let's start with the story, because I like to tell stories to give a context to my talk. And this talk came up in my mind last Christmas, when I've nothing to do, and I decided to learn Flutter for fun. And at the same time, I had to learn React Native for work reasons. And so I started with the classical stuff, so blog post, course, YouTube videos, and stuff like that. And then I decided to prove my skills. So I decided to develop an application, the same application in React Native and Flutter. And I'm only going to say that this app reproduces audio samples. If you are curious about what kind of audio samples, let's talk after. And another story, I did this talk a month ago at Droidcon Romania. And I had the incredible idea to update Keynote just 2 days before the session. And I got some issue with the magic move and the code. And there was this beautiful artifacts and rendering issue during the session. I only discovered it during my presentation. And so of course, I tell everyone on Twitter, and a guy answered me to tell him about the thing. And guess who is this guy? He's the engineering manager of Keynote. And so I decided I send the slides to him. And tomorrow, and yesterday, I opened the App Store, and I saw this. So, what I'm going to do, I'll update the Keynote or no? What I do? Okay, let's ask to the Twitter. And guess who guy answered to me? Yes, that guy. And he said maybe. So I decided to update Keynote, but I didn't try it if the bug is still there. We'll find it together later on, and so it's his fault if the rendering or there is any bug on Keynote. So, besides jokes, let's start. And today we are going to see about the language, but I focus more on UI, how to build UIs, and how the two frameworks works under the hood. And next, we are going to see a little example extracted from the application that I developed. Okay, let's start with some history that is already useful. And React Native, the first idea of React Native is born on 2013 during an internal hackathon on Facebook. And 2 years later, a first preview has been released, and a few months later, the first stable release, the first stable version has been released and open sourced. And Flutter instead is more is younger, and a first kind of version has been unveiled during Dart Dev Summit on 2015. And 2 years later, the first preview has come out during the Google I/O. And next, last Christmas, the first 1.0 version has been released. And despite its youngness, Flutter is gaining lots of famous. And these are Google Trends for React Native and Flutter. And as you can see, Flutter is reaching and almost overwhelming React Native. And another sign of trend are the GitHub repositories. And there are many, the stars are basically the same, but there is lots of issues on Flutter, but this can be also a good and a negative sign. Lots of, I have to say that also Facebook has a little aggressive bot to close issues, and maybe the Flutter repository not. But okay, let's talk about language. But before, a quick survey: how many of you are a mobile developer? Okay, the other are web developer. Okay, so maybe you can close your eyes for the next slide. And because the language of React Native is JavaScript, and JavaScript for object-oriented devs are kind of dead for many things. For example, the type handling that is different in JavaScript. For example, if you not pay attention to the type, some random stuff can happen, and the app can silently fail and doesn't tell you where it explodes. For example, I took, I guess, 1 hour to figure out where the bug was. So please make a sign, explode, an exception, something, not silently fail. And another kind of issue can be the different prototype and the fact that there is lots of confusion in the ecosystem. In fact, there are many libraries for doing the same stuff. And to avoid some of these issues, I highly encourage you to go with TypeScript or Flow. When you begin a project, don't do our mistake. And that because I cannot do a talk by talking about JavaScript without a meme. When I read this, what the fuck? Okay. Now I can make a tick on my to-do list of blame JavaScript for the day. Okay, tick, done. Okay, let's talk about Flutter now. And Flutter uses Dart, that is a language invented by Google in 2011. And basically, Google wanted to fix that the trouble with JavaScript by making an object-oriented friendly language. And in fact, for example, Dart is strongly typed, but the type can be inferred also at runtime. And the result is a language that is easy to learn for object-oriented dev, but also for web dev. And another interesting feature about Flutter, about Dart, is the capability to generate native code and transpile into JavaScript. This is a useful feature that we are going to see later on. Okay, since there are a lot of web developers here, this is not a crusade against JavaScript. I'm only reporting my experience, and of course can be different from yours, and everyone in the world could use whatever they like. Okay, after this bit longer introduction. Let's start with let's go deeper with the UI, and let's do with some code. It's boring not seeing any code. And so, this is an example. This is an hello world in React Native, and this is a hello world in Flutter. And let's move to React Native. And this is not the part where the code is broken. Is next one. And as you can see, here there is the render method. And the render method in React is the main entry point of our application, of the component, and where we declare all the stuff that we want to view in our UI. And so, in this case, there is a view with inside a text. And view and text are components. And components are the basic building blocks to build user interfaces. And you can, of course, fit together many components to create complex components or custom components. And to declare components, you have to deal with a DSL that is called JSX, that is a mixture of JavaScript and XML code. It's very simple, you can learn it in 2 minutes. And all the customization are made with the CSS, that is a version that usually matches 98–99% of the CSS used in the web. And these differences, you can find these differences only on runtime when things not work as expected. And of course, there are many components provided by Facebook that you can use. You can find a list on the documentation. And you can also use components developed by by other developers. In the NPM Ocean, you can find any kind of stuff. Okay, let's move to Flutter. And in this case, a disclaimer, this is a simple hello world. So there isn't, usually you don't do stuff like this. And you call the run up method once on the entry point of your application, and then you call a main widget that is declared outside, but this is a stupid hello world, so whatever. And in this case, we have a center widget with inside a text widget. And guess what? Widgets are the basic building blocks for build the UI in Flutter. And they took inspiration from React Native. Is written in the Google wrote in the documentation that it takes inspiration from React Native. And in Flutter, everything is a widget. So it's a widget, the application itself, it's a widget. Our widget, the structural element of the application, so for example, button, menu, dialog, and stuff like that. Our widget also the customization of the building blocks, so for example, painting, opacity, color, and stuff like that. And are also widget the aspect of the layout, so for example, padding, alignment, and stuff like that. It's true, it's a bit weird at the beginning. You are usually you customize an attribute for changing the padding, but here you have to wrap your widget with another widget, and at the first time it's not clear, but after dealing with this pattern, it's simple. And of course, also here we have the list of components provided by Google, and we can also use our components defined by other people and publish it on the internet. Okay, so in Flutter we remain in the Dart context. Instead, in React Native we have to deal with a DSL that is very easy, and we can, in both frameworks, we can modularize the user interfaces and do it. Because if you don't do it, you can find source code with very long lines, lots of nested stuff, and you doesn't understand anything in 2 minutes, and so do it. And you should also use a state management framework in your application. So in this case, because you can in this way separate the business logic from the presentation logic, and you can share the state between different parts of the application, and you can have a more testable application and stuff like that. And there are many ways to do it. In React Native, you can use a naive method that is a name totally made up by me, and we are going to see it later on. You can use Redux, you can use Mobix, you can use tons of other framework. And also for Flutter, there are many methods. You can use, again, the naive method that we are going to see later on. You can use scope model, you can use block, you can use Redux, you can use other things. These are the main important. And if you're trying with Flutter, I suggest you to go with the scoped model. Instead, if you like streams, you can use block. The concept of block is very similar to RX Java and stuff like that. Okay, these are some resources. I'll share the slide later on. And okay, the way we have declared the UI later on, before, has a name, and its name is Declarative UI. And it is different from the classical pattern that we have seen in the mobile world. In fact, in the mobile world, we use an imperative style where we go to the view owner, we ask for an instance of the view that we want to update, we receive this instance, and then we update. So for example, for the guys that are mobile developer, when you do find view by ID, you are doing this stuff, and then you update all your view with maybe a long if-else based on error or normal or loading or normal state. With the declarative UI, instead you declare the state of the application. So, for example, loading state. How your UI should look like when it's loading, when there is an error, when there is the normal stuff, and then the framework manages all the changes. And this is a pattern. Sorry. Okay. And this is a pattern that is largely used in the web world, but in the mobile world has been introduced by React Native and now with Flutter because it takes inspiration from React Native. But also the native actors are going into this direction. In fact, in the latest Google I/O, Jetpack Compose has been introduced, and Jetpack Compose is a toolkit to build a UI in a declarative way on Android. Is based in Kotlin. If you wanted to try it, you can download the latest canary of Android Studio and try it. It's not yet ready for production, but you can try it. And basically, you can define a function in Kotlin, and then this function will be converted into a UI hierarchy. So, for example, in this case, a text widget will be built by showing this name, and every time this name changes, also the entire UI changes. And it's not only Google, but also Apple at the latest WWDC has presented a stuff to do declarative UIs, and its name is Swift UI. And as you can see in this snippet, it's very similar to the example that we have seen before, but it's Apple, and this stuff is ready for production, but is compatible only with iOS 13. So takes some years to be introduced in a production app. Okay. Enough talking about UI. Now let's move under the hood to understand how this framework works. And we start with React Native. And in React Native, there is an infrastructure that is built at runtime, and the name of this infrastructure is Bridge. And basically, is a bridge between the JavaScript part and the native part. And it basically sends event between the two sides. So, for example, when our application is opened, the native part communicates the app opening to the bridge that serializes the information. So it generates a JSON and passes this JSON to the JavaScript part that processes the events. So it decides that it's time to render for, some views. So for example, the view with the text that we have seen before, and then communicates this thing to the bridge that generates a JSON and passes it to the native part that finally instantiates our views. And all this kind of communication is, of course, causes, of course, some delay. For example, in the list or in very complex layouts, because every time we touch the screen, there is this communication. And to avoid some overload, there is also a queue that is flashed every 5 milliseconds, but the delay remains. And in fact, Facebook is working to a new architecture with a codename Fabric. It's still in development, but what they want to do is update the UI in a synchronous way, and by getting rid of the bridge and the serialization that generates slowness. And basically, there will be an interface between JavaScript and the native part. So there is, there will be, for example, like a remote procedure call between the two parts. Of course, it will be quicker. Flutter instead uses an engine written in C++, and also the bridge of React Native is written in C++, just FYI. And there is an engine with a graphic library, and the graphic library is Skia, that maybe you have already heard about it because it's used in Android and Chrome. And this graphic library draws the widget in a canvas. So with a graphic library, everything is quicker because it uses the GPU and stuff like that. But the cons is that the app size will be larger because, of course, we have to ship this engine in the APK or in the IPA. And so with the React Native, we have a correspondence between native widget and the widget declared by JavaScript, so the components. Instead, in Flutter includes its own widgets. If Google or Apple updates the text view with, I don't know, with flowers, React Native, on the paper, should work and render the flowers. Instead, the Flutter no, because the Flutter team has to implement its widget with the flowers. And this is, of course, a cons. But the pro is that in Flutter, we don't have all this kind of translation time and slowness due to the bridge because there is no bridge. Okay. Now let's talk about some common interesting feature about the two frameworks. And the first one is the possibility to hot reload without losing the state of our application. So for example, we can update, if we want to update only the color or the size of a text, we can do it. and we can push the changes without reinstalling all the application again. And this is really useful. And in React Native is achieved by using a module of Webpack, and in just 2 words, it receives the new code, and there is a runtime that receives the new code and replaces to the old one. Instead, in Flutter, this is achieved by using a combination of ahead-of-time compilation and just-in-time compilation. For the debug builds, there is the ahead-of-time compilator that generates native code during compile time, so everything is fast. And instead, for the debug builds, there is a just-in-time compilator. So there is a virtual machine that receives the bytecode and receives the new bytecode and replaces to the old. And so the auto reload is possible in this way. And that's the reason why, if you have seen some screenshot of Flutter application on the web, there is a ribbon over there. In this picture there isn't, but there is here. That it says that you are using a debug build, and that because of this reason, and your application can be slower if you are using a debug build. Okay, another interesting feature is and this feature is the core of the declarative pattern, is the fact that only the components of the widget that really has changed are updated. And this is possible by maintaining a virtual representation of the UI and then update it accordingly. So, for example, in React Native, there is a virtual DOM. So, for this widget, for this component that is a web one, but is the same on React Native, a tree like this is generated, and it's a simple JSON. And if we will change the label of this button, so for example, we change the OK, another JSON, another tree is built, and then these 2 representations are compared using an algorithm that a diff comparison algorithm that is called reconciliation, and is an heuristic algorithm that makes some assumption to have a time complexity of big O of n. Instead, if we use the classical tree comparison, the complexity will be big O of n at the third. That is shit. And this assumption, one came from us, and one is defined by the system. The first one is that 2 elements of different types generate different trees, and the assumption that may come from us, because we are not enforced to do it, but there is a big yellow warning, and from time to time we are going to get pissed about this warning, and I'm sure that we are going to do this. And basically, for example, for the list, we have to provide a key that a key for each element of the list, so the framework will know that an item is changed, and so it knows what to render. On Flutter, instead, there is a tree representation. So, for example, for this menu, there will be a tree like this, and every node is a widget. And when the state changes, the node are called dirty. And when when there is an update on the state, the framework traverses the tree and decides what has to render and not. In this case, the comparison is not performed with a 3D diffing algorithm, but with with an algorithm that examines independently each child list of each item, and is a complexity of big O of n. But don't worry, enough talking about algorithm and complexity, even if it's so fascinating, and if I keep on, I talk for hours. Okay. The latest common interesting feature is the Frankenstein app, and this is another name made up for me. And with the Frankenstein app, I intend an application, a native existing application that has some feature, some screens, and some view that is done with a cross-platform framework. So, for example, we have a container. We have a container, a native container that renders the JavaScript feature of the JavaScript screen, and we have to generate a JavaScript bundle with this infinite command, and this feature can be useful for that kind of feature that maybe has to be iterated a lot, or a feature hidden below lots of paths in our application or stuff like that. And it's possible to do it also in Flutter, but it's already in preview. It's still in preview, and things can be broken. I tried to do it in our application at work, and I ended up with a Git revert. So don't do it at all. Okay, let's move to an example finally. And this is the part of the code broken, so I'm curious. Okay, this is a frame of the application that I've developed last Christmas. And, whoa, it seems working. Okay, Twitter is the new Jira. Okay, so let's give a look at the render method. And in this case, we have a view with a status bar, with a list. And in this case, before moving on, this is the key that we have to provide to the framework. And in this list, we provide the data, our list. And inside, we have to define also the render item. That is basically how our item should look like. So in this case, we have a list item with a title, with some style, and the style, as I said before, is done with a simple CSS. And then we have an icon, and so again some style with the CSS, and inside the on-press callback of the buttons, we have this magic keyword that is set state, and this is the naive method of setting the state. And in this case, I update a boolean for the audio sample that is reproduced. And when you basically you define a default state, and then when you want to update the state, you call this function with, of course, your updated params. And then when the set state is called, the render method is triggered again, and all the UI is rendered. And so pay attention to not call this in the render method. So instead, because it will create infinite loop, and I made it. Okay. And this is the code for our application React Native. Of course, there isn't all the code, but there is on my GitHub next we are seeing. And let's move to Flutter. And wow, it's beautiful. It works. Okay. So In Flutter, we doesn't have the render method, but we have the build method, and we have to override the build method every time we declare a new widget. And in Flutter, we can declare two types of widget, a stateless widget and a stateful widget. With a stateless widget, we cannot update the state. Instead, with the stateful widget, yes. And in this case, I start my application with a scaffold widget that it's a widget that provides a container for our application. So, for example, an app bar, a body, and in a scaffold widget, you can provide also material design stuff. So, for example, a floating action bottom sheet, and snack bar, and this kind of stuff. But in this case, I have only a body. And for a body, I have a container that has, as a child, a builder for our list view. And we have an item builder that basically is the same of our render item in JavaScript. And in this case, inside the render item, we define how our row should look like. So in this case, we have, again, a container with some margin and padding. And as you can see here, I wrapped my row, that it will be there, we'll see it later, with a margin, with a widget that provides a margin, a widget that provides a padding, and a widget that provides a decoration. And this is the pattern in Flutter. As I said before, it's difficult the first time, but next you get used to it. And don't worry, if you the IDE will help you. And if you have a nested UI, you want to add a margin in the very center widget, you can do it. You can do it with a shortcut from the IDE, and it manages all the kind. What time is it? I have to hurry up. Yes, I have to hurry up. Okay. So this is the example. It's all fault of the Keynote manager that I have added 10 slides for it. Fuck it. And also, don't waste time. Okay, this is in the oppressed callback. Again, we have the set state that is the same of the React Native one. If we update our UI in the set state, all this stuff all the build method is triggered again, and also here make sure not to build infinite loop. Okay. And we have also to provide the number of items that we want to render. And again, I already said. And this is our application in Flutter, and this is basically the same. Okay, I ripped out some code, so there is on my GitHub, the complete one. I have also, I worked a lot more on the not destroy. On the Flutter code, because guess what? I don't like JavaScript, and there are on my GitHub if you are curious. And conclusions. I talk about cross-platform, and cross-platform is not better than native. And if you hear from me saying that is better, please kill me because someone hacked me or stuff like that. And going cross-platform is a choice with compromises that is based on a specific situation. For example, you have a evolving feature, or you have a team that is not so able on iOS or stuff like that. And but you have to keep in mind that if the trouble became higher than benefits, you have to take a step back. I know that it's not easy because we are all humans, and we not declare defeats easily, but you have to do it. And Airbnb do it a year ago. But if you are curious about more on going cross-platform on native, I suggest you to follow the talk of Gianluca today at 3. And he goes through both technology and both business side, so it's interesting. And okay, you have made such a catchy and clickbait title. Tell me what to do. Okay, yes, you're right. And right now, React is more stable because it has a lot of back history. And Flutter instead is younger, but I think that Flutter is the future. And you should, if you are starting right now with from scratch with an application, go with Flutter. And instead, if you want to do some complex stuff like a Frankenstein application or stuff like that, go with the React Native because it's more stable and it works. Flutter is the future if Google doesn't drop it. Please don't. And because it has better performance than other frameworks, at least until Facebook releases the new architecture, but right now is more powerful. And of course, because Dart is a more modern language, JavaScript is good for the web, but is not a language for mobile. And also because there will be interesting stuff in the future. For example, Flutter for web, maybe we can have a single code base with a single business logic and then use Flutter also for a website. Flutter for web is in developer preview, in technical preview, so you can try it. And there is also the desktop support. Some days ago, the Dart team released a tool to make how can I say, an executable container for running our desktop application. So it's interesting. And that's it. Some useful links that you are definitely not seeing from us, but from here, but you can read it when I publish the slide. And that's all. Thank you. If you have some questions,